Hello everyone, I'm sorry for my English and for the quality of the audio in the video. I don't have any professional equipment, so sorry for that in advance. Anyways, I was trying to make a video about quality and speed modules. There is a common misconception that you can't combine them to produce more quality items. On one hand, it's true because the quality becomes lower and hence you're required to bring in more ingredients to produce the same amount of quality items. However, the resources in Factorio are basically infinite, so I was mainly interested in a different question. Can you produce more quality items per second with speed modules? So, without further ado, let's dive into some quick math. So, what do we actually need to perform our calculation? First of all, it is items per second, which is denoted by I. It is actually not needed, but we will consider it known. Second quantity is quality items per second, which is denoted by IQ. This is an unknown quantity, and we will need to calculate it. Next up is quality from quality modules, which is denoted by Q, and is equal to N times Q small. Here N stands for number of quality modules in the machine, and Q stands for quality from a single quality module. For thorough simplification, we will only consider tier 3 quality modules, so our Q small will be from 2.5% to 6.2%. Next is speed increase S. The first and the last two quantities are known, and the second quantity IQ is unknown. So our next quantity is quality decrease per speed increase, which we will denote by gamma. It is a special quantity because speed modules of different quality have different gamma. We will talk about it in a minute. And finally, our main concern will be W, which is quality items per second with speed boosts divided by quality items per second without speed boost. Now let's talk about gamma. From the game we can extract the following values of gamma for different qualities of speed modules. 1 over 20 for common speed modules, 1 over 26 for uncommon speed modules, 1 over 32 for rare speed modules, 1 over 38 for epic speed modules, and 1 over 50 for legendary speed modules. To do this, we simply look at tier 1 speed modules. Since they give us 1% of quality decrease, we will obtain the quality decrease per speed increase simply by taking the reciprocal of speed increase provided by these modules. And that's it. Now let's calculate IQ. It consists of three parts: items per second, which is I, quality, and machine speed. Quality is simply Q minus gamma S, and machine speed is 1 minus n over 20 plus S. The term n over 20 appeared because each tier 3 quality module lowers speed by 5%, which is 1 over 20 if converted to fraction. It is only left to substitute everything into this expression, and then to obtain W, we need to divide by IQ of 0. We are now left with this expression. Expanding it, we will obtain the following equation. It looks a little bit complicated, but we will deal with it. First of all, let's build some intuition behind it. Let's plot it for legendary quality modules and legendary speed modules for different number of quality modules n. We will obtain the following plots. As we can see, all of the plots have their own maximum, which are actually pretty high. Now let's find maximum of this function. To do this, we will take the derivative. Of course, since it's only a parabola, it is not necessary and maximum can be obtained by completing the square in this expression. However, coefficients of the parabola are pretty complicated, so it is really worth just to take the derivative. If you don't know how to take derivatives, then you just have to trust me on this one. This will be the only time in the video when it is required. So, after taking the derivative and equating it to 0, we will obtain the optimal speed increase S0. Substituting it into W, we will obtain optimal or maximal omega of S0. These two equations are our main equations which we will be using. They actually give us all the information we needed, but let's investigate a little bit more. We will view S0 as a function from n. This will allow us to find different areas of n. First, we have this border point where S0 is equal to 0. It means that maximum is located at s equals 0. So the optimal strategy for this point is not to increase speed at all, because we are already at the highest point without any speed modules. On the left we have this non-physical area. I call it non-physical since maximum S0 is located in the negative values, but since Factorio does not reward you with quality for speed decreases, this area is irrelevant. Finally, on the right we have physical area. In this area it is possible to increase number of quality items per second by combining speed modules with quality modules. Now let's take a look at the formula for W of S0. All we can do is draw a table with common values of n and different types of quality of speed modules. All the quality modules are considered legendary. Let's take a closer look at the table. We can see that it makes little sense to combine asteroid crushers with legendary quality modules with common speed modules. However, it makes a lot of sense, for example, to combine legendary quality modules in an assembling machine free with legendary speed modules. And here is the same table for optimal speed increase S0. Finally, let's conduct some experiments. Namely, we will try to obtain one of the plots predicted by the theory. Comparing the plots for common speed modules and common quality modules and legendary speed modules and legendary quality modules, we can see that the latter one completely shadows the first one in terms of potential increase in quality items per second. So, I have decided to recreate a legendary plot. To do this, I created this setup. Here we have a clock. Once it reaches 400k ticks, the production will stop. Next we have a counter of quality items. It just adds uncommon, rare, epic, and legendary items and outputs it as signal S, which stands for some. I also do have here a lot of inserters and common assembly machines. Why? We'll discuss it in a minute. Our speed boost ranges from 0 to 8.39. Don't forget the 0.2 which is coming from the quality modules. Of course it is better to conduct several experiments, gather statistics and so on, but we are not launching rockets into space here, aren't we? So one experiment will do. Now let's just start our production and wait with the game speed 40, even though my CPU can't keep up. After a bit of waiting, here are the results. The results are quite remarkable. You can see how close they are to the theory. However, I want to show you a different experiment. Remember those inserters, common assembling machines? Let's remove all but one inserter and change the assembling machines to legendary ones, and also change the maximum ticks to 100k. The results are on your screen. As you can see, it differs quite a bit from what the theory says to us. Why is that? Well, that is because the assembling machines are so fast, the inserters can't keep up to take out quality items from the single slot of the assembling machine, and because of that, assembling machines are idling. So that is another thing to consider when you think about the structure of your base. So I think this is it. I also made a very small table for you to be able to calculate S0 and W of S0. It works, however, only with tier 3 speed modules and quality modules. To use it, just make a copy of it. It will be in the description. So sorry again for the quality of the video and for my English. I hope you learned something new. I don't know if somebody will be using it or not, but whatever. I just wanted to share this with the community. Have a nice day and goodbye.